Hello, we continue our series of overdue videos in which we do not talk about setting up functions in the Sigur software or connecting to specific peripheral devices with the system controller, but about organizing certain types of access points that are most commonly found at various facilities. We discussed the organization of the door as a key element of access control within the enterprise in a separate video. In this video, we will look at a space such as the checkpoint, which is usually located on the perimeter of the enterprise and performs tasks not only to restrict the passage of employees, but also of company guests. And the key element of the checkpoint is often the turnstile. For convenience, we will divide the video into logical blocks, based on the tasks that the checkpoint enterprise solves. So, first of all, a checkpoint is a space equipped with turnstiles, which in turn facilitates the free passage for employees or guests of the enterprise. The security of the facility directly depends on how flexibly the access control system can manage different types of turnstiles. Secondly, each passage through the turnstile must be personalized. This is primarily important for further analysis of the accumulated data. With anonymized text, it is impossible to track working hours, one of the popular functions of any access control system. Thirdly, let's talk about ensuring a high level of security by increasing the strictness of access through additional passage conditions, using the Antipanic function in case of emergencies, and properly designing the entrance group. And finally, we will address the issues of process automation. We will talk about the use of turnstiles for counting employees' working hours, as well as consider one of the key tasks of the checkpoint, organizing guest access. Before moving on to the first section, it is worth noting that Sigur controllers have everything necessary to manage any type of turnstile, as well as all associated equipment. No additional expansion modules or similar devices are required for this. All additional devices, whether various buttons or sensors, are generally connected to the discrete inputs of the controller. Names differ. E510, D1, D10, E2, E4, PS, RT, E510, barely 4 PS, card. Depending on the chosen model, the number of access points of this type that the controller can manage simultaneously will vary. For the E510 model, this typically involves 2 turnstiles with any type of control, whether it is potential, using only 2 relays, or pulse, using 3 relays at once. The E2 controller model can manage 1 turnstile, while the E4 model can manage 2, both with any type of device control. It is worth noting that in Sigur, any controller can simultaneously manage different types of actuators. The E4 controller connects to a turnstile and 2 doors with one-way access control. When rears connect via OSTP, it controls both directions. So, let's talk about the checkpoint as a space equipped with turnstiles, which in turn facilitates the free passage for employees or guests of the enterprise. We will focus on the technical differences between a turnstile and a door, the features of various types of turnstiles, and the approaches to choosing a particular type. The fundamental difference between an access point door type and a turnstile is managing the flow of people and security. A door does not control the number of people passing through it at once, which directly affects the level of personalization for each passage and the overall security of the facility. The turnstile allows only one person to pass at a time, ensuring more accurate tracking of passages, which is very important for counting employees' working hours, and also prevents unauthorized access to the enterprise's territory. Today, there are several types of turnstiles: tripods, rotary, gates, swing gates, and optical. Each of the listed types can be divided into 2 groups based on the type of control. Potential, when the turnstile requires a long-term supply of voltage to open, and control is carried out by 2 relays, one for entry, the other for exit. An impulse, when the turnstile requires a short-term supply of voltage to open or close. In this case, control is usually carried out through 3 relays, one for entry, another for exit, and a third for locking the turnstile bars after passage. The listed types of turnstiles differ not only in design or control logic, but also in a number of various parameters. For convenience, we have highlighted the most important factors when choosing a turnstile. Let's take a closer look at them. Dimensions. This parameter refers to the physical size of the device. It is important to consider when designing a company's entrance, as the compactness and seamless integration of the required turnstile into the space affect both the number of devices needed for access control tasks and the interior design of the room. Throughput. Perhaps one of the most important parameters, it determines the speed at which access objects pass through the turnstile. Depending on the daily load of the company's entrance, this parameter allows for the mitigation of queues and downtime during peak hours. The quality of flow separation. The quality with which the turnstile separates the flow of people to allow one person at a time directly affects the registration of each individual employee or guest of the company. This, in turn, has a direct impact on the quality of time tracking and the personalization of entries. The level of passage protection is a parameter responsible for the possibility of bypassing the turnstile in any way, thereby entering the facility without identification. As a rule, this parameter is increased due to the design of the turnstile. Additionally, one of the important parameters of the turnstile to pay attention to when choosing is its mechanics. There are two types of it, normally closed and normally open. With the closed type, the turnstile opens each time authorization for passage is received, providing better security, but imposing higher demands on the locking mechanism. In the event of a power outage, such turnstiles remain closed. Opening for passage in case of an emergency is done manually. When open, the mechanism activates in the event of unauthorized passage, contributing to longevity of the locking mechanism and lower energy consumption. When power is lost, the turnstile remains open. Sigur supports the management of any turnstiles. The system takes into account the features of many popular models, and the flexible adjustment of various parameters allows the system to be configured as needed. We guarantee their correct operation and provide a connection diagram for the controllers. If the model you need is not on the list, contact us and we will definitely study it and offer a ready-made connection scheme. Now let's talk about the identification and recording of passages through the turnstile. In this section, we will examine various types of readers and identification methods, the specifics of processing signals from turnstile passage sensors, and the system's capabilities for registering a passage in case the identifier is forgotten or lost. Let's consider the main identification methods and their impact on the passage speed of each access point. Since the turnstile is a full-fledged access point managed by a controller, the devices for passage identification will, in most cases, be linked specifically to the capabilities of the controller. Sigur controllers, in turn, support the connection of any models of reading devices that have standard output interfaces such as Vigent or OSDP. The choice of the appropriate communication interface depends on the specifics of the facility and the controller model. For example, any reader with a Vigent interface can be connected to the E510, while controllers of models E2 and E4 can connect readers via both the Vigent and OSDP interfaces. Let me remind you that OSDP is an open interface. This allowed us to develop our proprietary configuration, SSDP, which enhances the interaction capabilities between the controller and the reader, both in terms of basic reading and indication settings, as well as firmware updates directly from the Sigur software interface. For more details, watch the separate video. Overall, the freedom to choose a reader allows the system to use the identification method that is most convenient for the staff or guests of the company. It is worth noting that an important parameter when choosing readers can be the technical feasibility of installing it directly on the turnstile. Depending on the manufacturer and specific model, the turnstile housing can be either universal, meaning it can accommodate any type of reading device, whether card readers, QR code scanners, or biometric systems, or monolithic, not being able to replace reading devices flexibly, and with built-in readers by the manufacturer. When it comes to passage speed, using different types of reading devices, contactless card readers, QR code scanners, or facial recognition devices are probably the fastest options. Therefore, if the speed of passage during working hours plays a key role, it is worth focusing on such devices. If the speed of passage is not as critical as the level of security, then the focus can be on selecting biometric readers, fingerprints, palm veins, retina scans, and others. In such devices, the identification time depends on the size of the personnel database. Depending on the manufacturer and model of the turnstile, the devices for recording passages may vary. It is worth noting that if the access control system is to offer analytics in the future, like tracking employee working hours, it is essential to ensure that all entries are accurately recorded in the system. First of all, connect all turnstile passage sensors to the controller directly, or through a crossbar if available. Additionally, this approach will also support the operation of the zonal control function, which can be useful in emergency situations when information about an employee's location is critical. As a rule, there are 3 ways a turnstile can send a passage signal to the controller. Let's examine each of them. The first is the simplified interface. The turnstile has 2 outputs, and when passing, one is activated according to the direction of movement. The first relay triggers the sensors in the entry direction, while the second one handles the exit direction. The single-wire interface, the turnstile has only one output, activated whenever a passage occurs in any direction. And the third is direct sensor transmission. The turnstile has 2 outputs and activates them sequentially with each passage. The activation order depends on the direction of passage. Entering, first the first one, then the second one. Exiting, it's the opposite. First the second one, then the first one. Such a scheme is not common, but it can be found in turnstiles from some well-known manufacturers. In the original documentation for the turnstiles, there is no concept of a direct scheme, simplified scheme, or single-wire interface. However, it is likely that there is a description of the sensor activation logic. Based on this description, you can see which sensor processing option is used and correctly set up the access point in Sigur. In the documentation for the controllers on the site, you can find the connection diagram and recommendations for settings, with direct instructions on the type of sensor processing logic. In Sigur, all passages are recorded, including those authorized by the security guard's console, as well as passages made when the turnstile is unlocked, including mechanical unlocking. In a situation where an employee arrives without an identifier, it is possible to record their passage using the built-in functionality of the client program on the Plans tab. For this, we have already prepared an example of a floor plan, and we explain in detail how to set up floor plans in Sigur in a separate video. So, in the client program, let's go to the Plans tab. Let's simply select the floor plan we are interested in. Then, using the toolbar at the top of the screen, carefully click on the Add Access Points button. After which we place the access point on the plan location. The settings for the element are displayed in the lower left part of the screen. In the access point parameter, you need to link our element on the plan with the actual access point, which in our case is the turnstile at the entrance. Now, on the top toolbar, click the Edit Existing Objects button. After which we will be able to interact with our access point using the right mouse button. In the drop-down menu, we can manage the status of the access point and also register passages. Moreover, the registration of passages can be either anonymous or personalized, such as we can see the results of such passages on the Observation tab. In the case of allowing anonymous passage in a certain direction, the system opens the access point but registers this event as a passage authorized by a button. In the case of a personalized passage, the system allows you to select a specific employee, upon whose selection the access point is unlocked, and the events in the system are recorded as the passage of that specific employee, even though they did not actually present an identifier. Now let's take a closer look at ensuring a high level of security by increasing access strictness through additional passage conditions, using the Antipanic function in case of emergencies, and properly designing the entrance group. Often, at the entrance of an enterprise, the task is not only to restrict free passage, but also to conduct additional checks on employees before they enter the premises. Depending on the access strictness and the facility, the turnstile can be equipped with additional equipment like a breathalyzer, thermal imaging, or a facial recognition terminal. In addition, metal detector frames can be installed in front of the turnstile, which typically have a special signal output for connection to the access control system. The detector sensor detects a known exceedance. The device will send a signal to the controller, which in turn can block the turnstile to prevent the violator from passing through. At the same time, all the additional equipment listed is connected to the same controller as the turnstile itself without any additional devices. Additionally, in Sigur, various special logics can be configured, including complex ones, thereby setting additional passage rules without using external equipment. For example, requesting security authorization, zonal control, and preventing repeated passages, limiting the number of people in the area, identification by multiple criteria, and escorted access, often in enterprises or educational institutions. A security staff member is directly involved in access control, meaning they are physically present near the access points to monitor events in the workplace and respond promptly in case of emergencies. The workstation of such an employee must also be set up in the most convenient and efficient way possible. For example, the operator's permissions in the software and the event monitoring window of the system should be configured so that the employee can perform their duties properly without needing to solve any tasks through the system settings. We discussed this in more detail in a separate video. Continuing the topic of safety, it is essential to address the equipping of the entrance, particularly turnstiles, with features for quick response and safe evacuation of employees and guests of the enterprise in case of emergencies. To address such tasks, various emergency unlocking devices are in high demand. They can be either manual or automatic. The first ones, unfortunately, do not have an established name, but they are often referred to as manual security and fire alarm. As a rule, they are a familiar green plastic casing with a push device that locks in the pressed state, which can be reset with a special key. When pressed, the button breaks the circuit, sending a command to the controller emergency unlocking access points. These buttons are connected to terminals of the controller for emergency unlocking of access points. For the 510, these are the G&D VF F+, and F terminals, while for the E2 and E4 controllers, they are the F+, and F terminals of the EMC unlock unit. To simply activate the emergency unlocking inputs of the controller, go to the Equipment tab in the Access Point settings, then easily switch to the General tab. Uncheck the Show Only Basic Settings checkbox, and also activate the Use Fire Alarm sensor function. Here, you could also optionally specify which access points will not be unlocked during an alarm. In a similar way, the fire alarm control panel can be connected to the controller to automatically unlock access points in the event of a fire alarm. Thus, a turnstile linked to the Sigur controller will be automatically switched to an unlocked state. The bars can fold in two ways, manually by security guards, which ensures the possibility of organizing an evacuation even in the event of a power outage at the facility, and automatically with the support of the Antipanic function. Antipanic is a special optional mode of turnstile operation in which it lowers its bars, allowing for maximum throughput of the turnstile. This mode is usually used in emergency situations or for convenient passage with large-sized cargo. Using the Sigur controller, this function can be implemented for the controller to send a command to the turnstile control panel to activate the anti-panic mode. You need to select the desired access point in the client program on the Equipment tab and go to its settings, such as in the client program. Here, uncheck the box Show Only Basic Settings at this point. We look for the parameters indication line and unlocking factor. Then, we assign them to a free relay of the controller or an open collector type output depending on the connection scheme. Special attention should be paid to the methodology of designing the entrance area. Let's discuss the general rules for equipping the entrance, installing barriers, and passage forners. When equipping the entrance, consider the density of the flow of people simultaneously to avoid queue congestion. This is critical for large facilities with shift schedules, like schools and colleges, where large flows of people will pass through within 15 or 20 minutes at the beginning of a shift. For different turnstiles, the throughput varies. For example, for tripods, it is generally accepted to install one turnstile for every 500 people passing through simultaneously. In addition to the access control system equipment itself, barriers play an important role in forming the passage area. When properly positioned, they not only direct the flow of people through a designated area, but also prevent unauthorized access and incorrect recording of authorized entries. Tripod turnstiles are most commonly used in access control systems. They are quite compact, can even be wall-mounted, and come in a wide range of models that differ not only in functionality but also in design. Additionally, their cost is significantly lower than other types of turnstiles. Some tripod models are more demanding regarding the placement of barriers, as incorrect fixation of personnel passages or missed passage events can occur in some cases. To avoid such errors, it is necessary to properly install the barriers used in conjunction with them. Specifically, a passage former can be a special fence section, another turnstile, a wall, or a column. It should be installed perpendicular to the top bar of the turnstile at a distance of 5 or 6 centimeters from its edge. The length of the passageway shaper should be between 80 centimeters and 1 meter. When forming the passageway zone, it is necessary to consider fire safety requirements for the proper organization of evacuation exits from the premises. In cases where the passage area with an installed turnstile also serves as an evacuation exit, the following criteria should be considered when forming such an area. The width of the cleared passage must be at least 80 or 120 centimeters, and the possibility of quickly clearing the passage must be ensured. The rapid clearing of the passage can be achieved through installations next to turnstiles of quick-release barriers, quickly opening panic gates or evacuation doors, equipping turnstiles with quick-release barrier elements. For tripod turnstiles, these are panic gate bars. And whenever possible, the use of panic gates and turnstiles with normally open mechanics, meaning they remain open when power is lost. So, let's move on to discussing the automation of the process through the proper organization of the enterprise's entrance group. Let's start with employee time tracking. At many enterprises, the checkpoint is the only access point to the facility's territory. The data on employee passages can be used for analytics and time tracking. Sigur supports schedules of any complexity with various algorithms for calculating worked hours. Therefore, for each group of employees, it is possible to create a schedule that fully meets the specifics of their work. In addition to organizing access control at the entry, the system can be expanded by equipping additional passage points, faculty offices, laboratories, workshops, and storage areas. In addition to enhancing security, This can also increase the accuracy of time tracking. This can be relevant for employees whose work hours are counted only when they are physically present at the workplace. In this case, to improve the efficiency of time tracking, so-called pocket readers can be used. These allow for the detection of the presence or absence of an employee's card in the special pocket of the reader, thereby enabling even more accurate calculation of the actual working hours of employees. For more details on how to set up and work with time tracking and pocket readers in Sigur, we explain in a separate video. The entrance group of the enterprise, in addition to its main tasks, is generally a key element for organizing guest access. Sigur allows organizing work with visitors through its own interface, without using third-party software. You can automate guest pass management. Besides using desktop software, you can organize the submission of applications for temporary passes through the web interface. A visitor can submit a request to visit either from their personal device through a web form or by visiting the entrance group of the enterprise and registering at a special terminal. All of this eliminates the direct involvement of the operator in these processes. The identifier can be either a familiar contactless card issued upon visitor registration or a QR code that is automatically generated on the Sigur server. For reading QR codes, Sigur supports any readers with a Vigent or OSCP interface. Information from the QR code is transmitted to the controller and processed by the system as a regular card code. We provide more details about the functionality of web applications for visitor passes in Sigur in a separate video. If guest access at the enterprise is managed through the issuance of temporary contactless cards, there is a logical need to automate the process of collecting these cards from visitors after they leave the premises. In Sigur, you can set up automatic collection of passes using card collectors. This will reduce the time spent servicing visitors and allow for the automatic retrieval of passes when guests exit the premises. The card receiver is directly connected to the Sigur controller along with a turnstile or another control device. The control logic is implemented in hardware. No interface boards or additional devices are required to work with the card receiver. To exit the premises, the visitor must place their pass into the card reader. Only then will they be able to pass through the turnstile. At the same time, a scheme can be implemented where permanent employees can pass through the access point either by presenting their identifier to the reader or through a card acceptor with automatic card return, while guests can only pass through the card acceptor. In Sigur, you can set up where a guest cannot pass through the turnstile when leaving the premises. To pass through, he will need to hand over his pass to the security officer, who will authorize the passage by presenting the handed over pass to their reader, located in a place inaccessible to the guest. After that, the guest will be able to leave the premises. A passage event will be generated, and the corresponding note about the return of the pass will be recorded. So, with you, we have covered all the important nuances related to the equipment of the access control system. In addition to employee access control, there are tasks related to organizing controlled vehicle access to the facility. We will talk about this in the next video. That's all from me for now. See you next time.